Assalamualaikum and hi to everyone. So welcome to exercise number 8 on the title of overhead line model. So today I will show you how to carry out experiment number 1 or activity number 1, namely no load performances. If you refer to the figure 8.2, so it shows you the no load operation, especially the diagram, the wiring diagram, and this is how we experimentally set up all the installation. Okay, we start with our three-phase supply over here. Okay, and then we have all the breaker. Okay, and then we move on to the transformer unit, and we do have the three-phase meter over here to do all the measurement before the transmission line model. Okay, so this is the output part of the transmission line model, and again we connect to the three-phase meter, and here we can actually read all the voltage, okay, the reading of voltage, reading of current, the reading of P, the actual or the real power, Q, reactive power, etc., etc. Okay. So now based on your lab sheet, so if you go to step number 5, so you are required to record a value of U1LL, the line to line voltage, number 1, and then you have to record U2L2L or line to line voltage, so for the second reading, as well as P, power, and also Q. Okay, so this is where you can actually record down all the reading. Okay, so you push button U, okay, this is button for voltage reading, for example, and it will give you simply the reading of V. Same goes here. Okay, so this is for U1 line to line, the first reading, so it goes approximately to 336 volts. So 336 volts for U1 line to line. And then what about U2 line to line? So you may measure from here. Okay, again hit the U button, and this will give you around 520 volts. So this is the answer. Okay, next is for you to read or to record the value of P in watt. Okay, if you look at carefully, so there is a P, Q, and S button, and again you hit this particular button and give you the reading of P, Q, as well as S. Okay, the P here, or the P reading over here, give approximately 2.8 watt, and finally the reading of Q, so give us approximately negative 66.8 volt. Okay, so now again back to your procedure. So if you come to step number 6, so they require you to calculate on the value of Q, okay, the reactive power, so using the provided equations. So don't forget to multiply by 3, since the value I told you earlier is in single phase. Okay, so multiply by 3 again, so from the value you read or the value I told you earlier. So thank you very much. So I will show you later on how to carry out activity number 2 and all the related data reading. Thank you very much. Let us continue with exercise number 2 or activity number 2 with the title of concept of operating capacitance. So this is our experimental setup. If you compare to activity number 1, so we have actually one additional component, namely the line capacitor. Okay, but before that we need to take out of the bridging plug or the connecting plug between line 1 to line 2, as well as line 3 and the neutral. Okay, so we leave the transmission line model themselves without the connector, but again we put in the line capacitor. Okay. It is now to operate the system, and again we will record down the voltage value, the U1 line to line, so the U2 line to line, as well as the reading of the reactive power Q. So let us wait for the meter to give the reading. Okay. So now, so again we hit the U button, means the voltage button, to get the reading of voltage. Okay. So similarly for here, so you hit the volt button or the U button. Okay. Alright, then now again, so you can simply read from here, the value of U1 line to line is approximately 340 volt. Meanwhile, for U2 line to line is approximately 450 volt. And for Q, so the reading is about negative 66.5 var. Okay, and then again, when you come to step number 7, so you must compare the result with those in activity 1. I mean the calculation of Q. Alright, so use again the equation provided in activity number 1 in order to obtain the calculated Q and make your comparison, and of course you need to discuss later on. Okay, thank you very much. We see you in activity number 3. Okay, now we continue with activity number 3, line with increased operating capacitance. If you refer to the lab sheet number 92, figure 8.4, so it shows that the connection or the installation of a no-load operation line with increased operating capacitance. So it's nothing much different if compared to activity number 2, because for this particular activity, we just reconnect all the plug over here. Okay, between line 1, line 2, and 3, as well as neutral. So we have few pieces of connector which we reconnect in activity number 3 and 10 to increase the operating capacitance. Okay, and again from here we may see the difference between U1 and U2, the sending and also the receiving voltage after we increase the operating capacitance in the transmission line model. Alright, so now again, after we switch on everything and they are all operating in a good operation, and here is the again meter, the 3-phase meter, to read the value of U1, U2, as well as the Q. Okay, so again press the U button and we see that the reading gives approximately 340 volt. Alright, the descending voltage or U1 line to line. And then what happened to U2 line to line, the receiving voltage, sorry, and it gives approximately reading of 302 volt. Okay. Come back here and press button P in order to read the reactive power value, whereby we obtain approximately minus 147 var. Okay, again you need to compare the result, the finding over here with activity number 1. You reuse the probe equation and try to calculate the Q again and make your comparison as well as discussion. So again, we will see in next activity number 4. So welcome back to activity number 4, the ohmic-inductive load. Okay, now if you refer to figure 8.5, it shows the ohmic inductive load transmission line, the topographic diagram, and here it shows the actual experimental setup we have in our lab. So we have the supply, again we have the transformer connection, so the change to plus 5%, okay, this is mentioned in step number 2, okay, at the secondary side. And before we go to the transmission line model and all the metering, especially the 3-phase meter, and at the end of line, so we have two types of load, namely resistive load as well as the inductive load, or the ohmic load and the inductive load. So now we come to step number 4. To N terminal of line, connect a 3-phase balanced ohmic inductive load. So set the load begin with resistance R1, R2, R3 equal to 3. So that means so you need to change, or need to switch to level number 3. Okay. Similarly for R2, R3 set to 3. Okay, and then it says over here the inductive load L1, L2, L3 equal to 4. Here L1 change to 4, L2 again change to 4, as well as 3 change to 4. Okay, and thus you need to complete table of table 8.1. Inductive load is set to L1, L2, L3 equal to 4 or equal to 1.7 Henry. Okay, so with R equal to 3 and L equal to 4, so you are required to take a reading. Okay, first U1 over here, this button. Okay, so the reading is around 385 volt. Okay, and then you shift to I1, so you press button with I symbol, so it give around 0.2 ampere. And then next is P1, okay, hit button with symbol P, and this give approximately 338 watt. And then the Q here, okay, so the value is around 24 var. Okay, as you move on to the next column, you see the value of U2, which is the receiving voltage. It shows over here, okay, approximately 180 volt. So what about I? So again hit the I button, give about 0.8 or 0.4 ampere, and the cos theta or the power factor, so we have one special button here for power factor, so namely PF. Okay, so you hit the button and it gives you about 0.7. Never mind, since we have a lot of reading over here, so I will show you later on after this video the actual reading which have been completed in each particular table. Okay, this is only for demonstration. So what's next? For step number 7, so it asks you to repeat the measurement for inductive load of 0.9 and 0.64 Henry and record the table in results in table 8.3 and 8.4 respectively. So as you still in 8.7, sorry, table 8.1, so you see the R is now changed to 5. Okay, so L stick to 4 while R changed to 5. Here this is 3, 4 and 5. Just now we have 3, 4 and 5, 3, 4 and 5. So the data reading is similar to what we have done just now. Okay, so try to record down the value of U1, I1, P1, okay, descending voltage, current, power, as well as the Q, okay, the reactive power. And then the receiving part, so try to record down the U2, I2, as well as the cos theta 2. Okay, and then table 8.2, so you change the value of L to 5, which is equal to 0.9 Henry. So this is initially 4, so change to 5, 5 and 5, and back to your resistive load, change to 3. So 5 down to 3, 5 down to 4 and 3, 5 down to 4 and 3. Okay, so now we have L equal to 5 and R equal to 3. Again, repeat the same process to read the data. Okay, or out of VI, power factor, P, W, etc. etc. Okay, the watt I mean. And then next, change the value of R. Instead of 3 now, so regain the level up to 5. 3, 4, 5, 3, 4, 5, 3, 4, 5. Okay, and again repeat the same procedure in order to read the value. Okay, from the meter, of course. So next, table 8.3. So you may increase the value or the level up to 6 for L. Okay, up to 6, from 5 up to 6, from initially 5 up to 6. And what happened to R? Again back to 5. Sorry, back to 3. 5 for 3, 5 for 3. Okay, so we try to give a variety level of inductive load as well as the resistive load. Okay, and see what happened to element like voltage, current, okay, the power factor, the Q, okay, the reactive power, both descending and the receiving part. Okay, and again change the R after you're done with the data reading. So you change the R to 5, R5, R to 5. Okay, again read the data. And then as you turn the page to page 95, step number 8. So the question, the instruction there is to remove the connection of resistive load and repeat the measurement for L1, L2, L3 equal to 4. This means you need to remove for the resistive load. Okay, here. So just remove resistive load. So there is no any connection for resistive load. And then change the level of L, inductive load, up to 4. Here is 6, so down to 4, down to 4, down to 4. And fill up table 8.4, the data reading of U1, I1, KP1, etc. So this table also I will show you after this video. Okay, so hopefully you may copy the answer carefully and make a discussion in your report. So see you again in activity 5. Okay, now welcome to activity 5, which is the last activity of experiment number 8 on the topic of ohmic-capacitive load. Okay, in activity 4 previously, so we have seen how the inductive and resistive load give an effect to the performance of the transmission lines, okay, in terms of VU, power factor, the real power, the reactive power, etc., etc. And this time around in activity 5 particularly, so we want to see what happens if we have the capacitive load installed in our end part of transmission line. Of course, with the combination of resistive load, right? In a way that we tend to replace the inductive load with capacitive load. Okay. Now, if you go to your lab sheet again and turn to page 96 on step number 4, so it says that the loads begins with resistance R1, R2, R3 equal to 3. Now back to your resistive load set over here. So change R1 to 3, level number 3. So R2 level to 3 and R3 level up to 3. And then how about C? C change to 1. Level 1, level 1 and level 1. So next what you need to do, so complete table 8.4. Capacitor load is set to C1, C2, C3 equal to 1. So what we have done just now. Okay, just simply go to your 3-phase meter and change the button or the display to U, for example, and From there you can record down the value of U1 approximately 380 volt. Okay, so go to the next reading, which is I1. So press button I and take down the value. Again, all this value I will show you after this video, and you need to read it carefully and include it in your report. Okay, so now change to P1. Okay, and take down the value of watt, and then change to Q1, etc., etc. Okay, this is for the receiving part, the receiving end of the transmission line. Again, from here you may read, or you may obtain the value of U2, I2, as well as cos theta 2, the one stated in table 8.5. Okay, and then in step 7, so back to your resistive load over here. So it asks you to change, or no, so sorry, before step 7, so change the value of R. Instead of 3, so increase up to 4. So 3, 4, 3, 2, 4. Again, repeat the same steps in order to record down the value of VW, the I, the power factor, etc., etc. Okay, and then as you go to table 8.5, now change the value of capacitive load over here. So now instead of 1, it changed to 3. Sorry, level 2. Okay, level 2 means 3 microfarad. Okay, level 2. And then here, so down to 3. Okay, down to 3. So I am referring to table 8.5. Okay, again, here do the data reading. Okay, for all the table. And still table 8.5, you can see the value of R is now increased to 4 and 4. Okay, with still same level of C, the capacitive load. Read the data. Okay, table 8.5, so change again the value of C, the capacitive load, to 5 microfarad or level 3. Okay, I am changing to level 3 of the C capacitive load, while the R you need to down to 3. Okay, table 8.5. Okay, and then do the again data reading. So change the value of R again up to 4, record down the value or the result. So now if you turn to page 97 or page 98, step number 8, so again they ask you to remove the connection to the resistive load and repeat the measurement C1, C2, C3 equal to 3 or 5 microfarad. So simply disconnect or remove resistive load, and C equal to 3 or 5 microfarad, which is here, so the current level or the current value, and do the reading again. So again, the complete data for all these tables so will be shown after this video. Okay, thank you very much for watching. Have a nice day.